Hello students, today I will teach physics, and in physics one of the very important chapters uh, is light. So what is light? Light is an electromagnetic radiation. Without light we cannot observe any object. When light falls on any object we can see the object. Okay. Like other electromagnetic radiation, light is also very high speed. The speed of light is 3 into 10 to the power 8 meter per second. Light has dual nature. That is, one is wave nature, another is particle nature. Due to wave nature, we observe the phenomenon like diffraction or polarization, interference, etc. And due to particle nature, we observed phenomenon like reflection or refraction of light. So in your chapter mainly reflections and refraction are covered. So I will discuss about reflection today. So reflection of light. When light falls on a surface and sends back by that surface, sent back by the surface, this is called reflection. Suppose this is a surface. A light falls in the surface. Okay, and after falling on this surface, it bounces back in this direction. So this is called reflection of light. This is called incident ray. This is reflected ray. Okay. So I will discuss reflection. So there are two rules of reflection. Suppose this is a mirror. Any type of surface will not reflect totally. Usually shiny or polished surface reflect most of the portion of the light. Okay, any rough surface or any rough surface will usually absorb the light, or any transparent surface, suppose a glass will refract the light. It will reflect, but the fraction of reflection will be very low, or fraction of absorption will be very low. Most of the portion of the light will be refracted. This is called refraction. But in a mirror, mirror is a polished surface, or any metal, shiny metal or polished metal like silver, okay, they reflect light. Most of the portion of the light will be reflected. Some portion will be definitely absorbed, or some portion will be refracted, but refracted will be for transparent material, but reflection will be occur mainly in polished or shiny material or shiny object. So mirror is a good example where we observe the reflection phenomenon. So this is a mirror. Mirror, you can see the mirror is made of glass, and one side is glass and opposite side of the mirror is coated with silver. This is a silver coating. Okay, silver coating, and on the silver coating you will see some red color paint is coated. This is silver coating. Opposite side, and you can see in any mirror, and in some mirror you can see the red color paint is coated. So if a light falls in the mirror, it will be reflected in this direction. Okay, this is the normal of the mirror. Mirror is like that. The mirror plane, this is the mirror plane. My palm is a mirror plane, so incident ray is coming in this direction. This is the normal to the mirror, and reflected rays coming in this direction. So this is a mirror plane, this is a mirror plane, incident ray falling this direction, falling in this mirror in this direction. This is the normal, and this is reflected ray. Okay, so here incident ray, normal and reflected ray are in the plane of this board. So this is called incident ray, this is normal, this is reflected ray, this is angle I, this is angle R. So okay, so in this reflection there are two rules. Well, first rule is the incident ray, this is called point of incidence. First rule is the incident ray, the normal and the reflected ray will be in the same plane. Same plane means here incident ray is like that, normal is like that, and reflected ray like that. So this is the plane. Here this is the plane. And I'm showing some example. Suppose this is incident ray, this is normal, this is reflected ray. Okay, this is incident ray, this is normal, and this is reflected ray. So they are in a same plane. These three are in a same plane. You can see they are in a same plane. Okay, now here all normal, incident ray and reflected ray are in a same plane. This is the same plane. Now if the normal is like that and incident ray are that, are they now in the same plane? You cannot say these are not in a same plane. These are not in a same plane right now. Okay, when they are like that, these three are in a same plane. You can see here these three are in a same plane. This is the plane. Actually this is the plane. This is the plane. Here they are in a same plane. Here you can see the plane of this board. This is incident, these are in a same plane. But if it is like that, they are not in a same plane. Okay, they are not in a same. Normal is in another plane. Incident ray and reflected ray in another plane. Incident ray and normal in another plane. Incident ray and reflected ray in another plane. But here, in this case, the three is in a same plane. Okay, these three are in a same plane. So this is first. The first rule is the incident ray, the normal and the reflected ray will be in a same plane. Okay, these three in a same plane. And the second rule is incident ray, normal and reflected ray in same plane. But and second is the angle of incidence, that is I, and angle of reflection, reflect. Okay, this is called angle of incidence. I is called angle of incidence and it is angle of reflection, R. So angle of incidence equal to I will be always equal to R. You have to measure I, that is angle between incident ray and normal. It is not the angle between incident ray and mirror. Okay, this is mirror M dash. So incident will be angle of incidence will be the angle between incident ray and the normal, and angle of reflection will be angle between incident reflected ray and normal. So angle of incidence and angle of reflection will be same. These are two rules of reflection. There are two types of mirror. One is plane mirror, another is spherical mirror. Okay. First I will discuss plane mirror. How the image is formed in a plane mirror. Suppose this is a plane mirror. The surface is plane. It is not a curved surface. It is a plane surface. So suppose there is an object here. So how the image will be formed in this due to this plane mirror? This is an object. So initially ray will come from this top of this object in this direction straight. So here angle of incidence is 0 because it is falling directly in the normal direction. So this is incident ray, and the reflected ray will be in opposite direction. This is the direction of reflected ray. This is the direction of incident ray. This is the direction of reflected ray. Okay. Now suppose there is another ray coming in this direction. This is incident ray and the reflected ray will be in this direction. Here the angle of incidence and angle of reflection will not be same, but here the angle of incidence and will be same but not zero. Okay, the angle of incidence or angle of reflection will be same, but it is not zero. Some value may be 30 degree, 20 degree, because this is a normal. This is the angle of incidence, this is the angle of reflection. But here angle of incidence and angle of reflection both will be zero. Here the angle of incidence and angle of reflection will not be zero. In both these cases, the angle of incidence and angle of reflection will be same. Here the angle of incidence is zero and angle of reflection will be also zero. But here angle of incidence will be say something around 20 degree or 25 degree, or angle of reflection will be also same 20 degree or 20 degree. Whatever will be the angle of incidence, the angle of reflection will be also same. But it is not zero here, it is zero here. So the light is not directly meeting any point. This ray is coming in this direction and reflected ray is coming in this direction. Here you can say reflected ray is coming in this direction. Here also incident ray is coming in this direction and reflected ray is coming in this direction. So it is not meeting at any point. So if I extend this point here and I extend this point here, so this extend this back of this reflected ray, I am getting this point. Okay, so for point, suppose this is the object AB. For point A, I am getting image at point here A dash, just behind the mirror. Let's consider now the point B. So one ray is coming in this direction. This is the incident ray and reflected ray will be in opposite direction, this direction. Okay, another ray is coming in this direction and reflected will be, this is reflected, this is the incident, this is normal. Okay, so if I extend this point, okay, so I am getting B dash point for B. So from all the points of this object, I will give image point for image point. Okay, so I will finally get an image of A dash B dash for the object AB. For object AB, I will get the image of A dash B dash. This is object, this is image. Okay, so here all the rays are not meeting at any point. So this is not a real image. This is called virtual image. It appears to meet at A dash B dash. So image will be virtual. This is called virtual image. If the two rays, this ray meet at this point, two rays meet actually meet some point, then there will be real image. But here no ray is meeting here. This is appears to meet at A dash B dash. So this image is called virtual image. This is not a real image. I'll discuss real image examples in next class. So this is called virtual image, and the distance between the mirror to the object and the distance between the mirror to the image is same. This distance and this distance will be same, and size of the image will be also same. A dash will be equal to B dash. So size will be same. The distance from the mirror of AB and just in behind the mirror, the image will be behind the mirror, will be same, and it is a virtual image. So this is how, these are the characteristics of plane mirror. I'll discuss characteristics of spherical mirror, how the images are formed, in my next class. Okay, thank you.